right. This is my estimate, emphasis on the word estimate. What I'm thinking would be the schedule for the next 2 weeks that we have school. This week we kind of basically wrap up chapter 3 and there's a presentation. When we come back, that week has 2 days of review and a test. So approximately, that's the way it looks. Okay? So, questions on, what is it, 3.5? Yeah, 3.5. Euler diagrams, problem-solving tool. Go ahead. 33? Let's see if I have a... Sorry, got a tickle today. Well, let's try to take a look at this one, everybody. Number 33. The first premise, no wasps are unfriendly. Doesn't that basically say, in if-then form, if you're a wasp, then you're friendly? Look at that again. No wasps are unfriendly. So doesn't that basically say all wasps are friendly? And so therefore, isn't that if you're a wasp, then you're friendly? Okay, so please note the beginning of my picture. I've got my wasp circle surrounded by the friendly circle for that reason. Part 2, no puppies are unfriendly. Doesn't that basically say if you're a puppy, then you're friendly? Okay, so I drew my first puppy circle. Hang on a second. Why do I have a second one? I got to think about this. Anyway, just look at the black. Yeah, okay, look at my 2 black circles. Puppy circle 1, surrounded by friendly. Puppy circle 2, also surrounded by friendly. See, the thing is, we don't know if the puppy circle will intersect the W circle or not, do we? In fact, isn't it even possible that the puppy circle could surround the W circle, or could be surrounded by the W circle? It's possible, we just don't know. So try to keep in mind, there could be several places for the puppy circle, but the puppy circle has to be inside, completely inside of the friendly. Now let's go on. It says, which conclusion can be logically deduced? Okay, how about A? No puppies are wasps. Well, wouldn't that be true with my puppy 2 circle? But it would not be true with my puppy 1 circle. And since I don't know which one of those it is, I can't claim that they don't hit when I don't know. So that would have to be, that's not valid. How about the second one? If you're a wasp, then you're not a puppy. And that would be true if it's puppy 2 circle, but it would not necessarily be true if it's puppy 1 circle. So once again, those don't look too, I don't know. I would say neither. I see they gave you the choice, A, B, or neither. On that one, I'd have to say neither. What's that?
A, B, or neither.
That's what the book says. It says, use an Euler diagram to determine which conclusion, A, B, or neither.
Oh.
And then, and because neither one seems to work, I would have to say neither. Yeah. Oh yeah, I see what you mean. You thought there was a neither on the list. Gotcha. Yeah. Yeah, that's another way they could have done it. So that's 33. Other questions? Well, then I'm going to dig in and start because we got a fairly healthy lesson today, size-wise. I'm going to just ask one more time. One more.
Anybody wants to do? I just want to make sure I'm not shutting out. Always hate to turn down questions. Yes?
Number 27.
Okay. We'll see if I got it first. Yeah, I don't know if you're going to be able to tell what I did, but let's give it a shot. 27. Same kind of deal. All math teachers are Salseros. Whatever a Salsero is. Does anybody know, by the way? No, me either. Okay. Well, anyway, I better find out because evidently I am one. But anyway, all math teachers. So isn't that the same as saying if you're a math teacher, then you're a Salsero? And so I drew the math teacher circle surrounded by the okay. Part 2. Some math teachers do not sing hip hop. Oh, how sad. But anyway, so notice the key word there is some. So they do not sing hip hop, I'm just calling H. Okay? Or if they do sing hip hop, I'll call it H. So isn't it true, and you may think I'm crazy for drawing 4 of them here, but I drew 4 different hip hop circles. Isn't it true in all 4 of them that some math teachers are not in the H circle? Now some of you are going to say, no. And H2 and H3, no math teachers are Salseros. That's true. But doesn't it still satisfy the idea in math of some? Some means at least one. And so even with H3, are there some math teachers that don't sing hip hop? Yeah, there's in fact all of them. So, okay, now, with all 4 of those pictures in mind, let's look at the conclusions. Conclusion 1, some hip-hop singers are not Salseros. Some hip-hop singers are not Salseros. That would be true in H3, but it would not be true in H4. By the way, it would be true in H1, would be true in H2, but can you see that it wouldn't be true in H4? So that doesn't look good. How about the second one? Some Salseros, some Salseros do not sing hip-hop. Isn't that true with all 4 of the H circles? Aren't there some things in S that are not in H? Yeah. Because that one's true in every case, there she is. That's the one we want. So conclusion B is valid. Okay. Well, let me get down to the lesson here. Here it is, 3.6. Truth tables and the validity of arguments. Now, did you notice this title is almost identical to last time? Last time it said Euler diagrams and the validity of validity of arguments. This says truth tables and the validity of arguments. We're still looking for the validity of arguments. Last time we used these diagrams to help us determine them. The only problem with diagrams is, how do you know if you've ever drawn enough H circles, you know? Have you really covered all the bases? You always have a little bit of a thing in your back of your mind going, boy, I sure hope I looked at every possible scenario. Today, we've got a sure way to know you have not forgotten any scenarios, because when you do a truth table, you're really considering all possible outcomes. So, we're going to do the same thing today, but instead of using a diagram, we're going to use a truth table. And in fact, in the first problem I'm going to do it the old way meaning last lesson first, and then we're going to do it with the truth table way, and we'll see if they agree. And of course, they better. Teaching a math class, and if I taught you correctly, they should agree. So, here's the argument up on the top of the page. And it's actually number 1 on page 164. Maybe look at it so you get, because I've got it in symbols. In words, it's if you eat your spinach, then you can go out and play. If E, then P. So you see where I got that? And the second premise is, Alas, you did not eat your spinach. And the conclusion is, therefore, you cannot go out and play. Okay, let's make a diagram. Let's do this with an Euler diagram. How do I draw if E, then P? It's obviously two circles. Tell me which one has to be in the inside. The E. Correct? If you're in the E circle, you've got to be in the P circle. Okay, correct. Now, the second premise says we are not in E. So tell me, where on the Euler diagram is not in E? I know you're probably thinking, I've lost it by me asking you this question, but this is important. Yes, Matt.
Either NP or not NP.
So in other words, it could be here, it could be here. And of course, I mean anywhere outside. Yeah, you're right. There's really two general locations. So now look at the conclusion. Is it true that I'm outside of P? Yes and no. So can I claim it? No. So this is, and don't forget again, if look back at your assignment, did you leave any of your assignments where you did not write the word either valid or invalid? Because that's really important. I'll look for that. Okay, this one's invalid. So the truth table should come out the same way. So let me get into it. Let me set it up. Let me show it to you, and for the first time, show you how this truth table technique works. I mean, you know how to make truth tables, but you don't know how to apply it to an argument. So here we go. You notice I put some labels up here? I call this top line, if E then P, P1. By that I mean premise 1. I believe I already introduced the term premise to you, right? Premises? Yeah, we did that last time. Isn't a premise kind of like a given? Yeah. Given. If E then P. Or if you eat your spinach, then you can go out and play. The second given was, alas, you did not eat your spinach. Not E. And then a conclusion underneath there with a little therefore. So do you see why I call these top two premises? So premise 1, P1, premise 2, P2, conclusion. Notice in the truth table I use that same labeling. You need a column for each premise and for each conclusion. Well, there's only one in this case, but you notice how I made a column for P1, a column for P2, and okay, that's important. Now, help me fill out the truth table. So first of all, if E then P. Okay, what's the rule? Yep, only false when the first is true and the second is false, so this is the only one then that should be false, right? The other three should be true. Okay, not E. Well, isn't that just the opposite of the E column? So wouldn't that be FFTT? Whoop, I put it in the wrong place. Okay, now let's do not P. Isn't that the opposite of the P? So that's going to be FTFT. Okay, truth table is done, but you can't tell what's going on. Now here's the new part. Find all the rows in your table where all the premises are true. Now in this case there are two premises, but be aware that there are situations where you can have more premises than two. So that's why I use the word all. So where are all the premises true? Isn't this row? Yep, this row is, because you see how both the premises are true? I usually go through and circle that row. And isn't this row also? Yep. Would you agree those are the two rows where all the premises are true? This won't work because neither is true, and this won't work because both aren't. Okay, now look at your circled rows, and tell me, are there any false conclusions? Yep, right there. That tells me it's an invalid argument. So this guy right here, so let me just say again, for an argument to be valid, all circled rows must have a true conclusion. Yes? Could you circle them again? Because in those two cases, all the premises were true. See, right now we only have two premises, P1 and P2. But do you see how in those two columns, those are the only two rows where these two guys are both true? Okay. So that's the criteria for how you know which rows. Okay. Now, look at the rest of the rows that you circled. Do any of them have a false conclusion? Yes. Then it's invalid.
Okay, so wouldn't it just be every single thing? Wouldn't everything have to be true? Both? Like both the premises and the conclusion? Wouldn't you need like truths all the way across the board?
That's true. That's why that's invalid.
Okay.
But
so,
you mean, where did I get that F from?
like, why would you circle the row above it if the conclusion was false?
The reason you circle the rows is not because of the conclusions. You're only looking at premises when you circle rows.
Okay.
And since both these two guys, these are your premise columns. Since these guys were both true and these guys were, both those rows should get circled.
Okay.
That's the only criteria for circling.
Okay.
But then, in the next step, when you say, okay, now let's look at our circled rows, do any of them have a false conclusion? Yeah, and that's invalid.
Okay. Okay. I get it.
So that's like the next step.
Okay.
But you're thinking, yeah, I like your thinking. It was a good question. All right, everybody with me on that one? Now, do you notice that that agreed with what we found out up here from Mr. Euler's diagrams? Yeah, obviously, I'm not going to teach you something. I mean, this is going to do the same thing, so you're probably thinking this is a waste. It isn't, because sometimes drawing diagrams, man, is really rough. You got so many circles, you can't keep track of them all. This way, I'm absolutely positive I've got every base covered. And, you know, if you have a really complex problem, this is probably the way to go, because you can, this is for sure. The other one is cool because it sometimes makes it real obvious, but this one's got the advantage of being fail-safe. Okay, here's another one. This is number 2. Page 164, the problem says if you eat your spinach, you can go out and play. But notice the second premise is different this time. It says you cannot go out and play. Conclusion, you must not have eaten your spinach. Okay, so things are turned around a little bit there. We start off with the same premise, don't we? If you eat your spinach, then you can go out and play. If E, then P. That's premise 1. This time, you cannot go out and play. That's not E. That's not P. So the second premise this time is not P. And the conclusion is, you must not have eaten your spinach, not E. So we got the same players, but they're in a different order. You see that? This may change the problem. Okay, let's fill it up. Should we do the Euler? I'll do one more Euler diagram. After this, I won't. If E, then P, well, that looks the same as it did last time. There's E, there's P, and it's not P this time. Isn't there only one place you can be for not, well, it's got to be somewhere on the outside of the outer circle. Would you agree that therefore we have to be outside of the E circle? So doesn't this one appear to be valid? Sure does. Okay, now let's try an Euler. If E, then P. Same deal. The only false is when the first one is true and the second one is false. Not P. False, true, false, true. Not E. False, false, true, true. Okay, now find all the rows where all the premises are true. Isn't there only one this time? And what about the conclusion? Da-da-da-da-da. Sure, there are no false ones this time, therefore, you can do without the fanfare, but this one is valid. Yeah, go ahead, Josh.
When you're correcting the test and assignments and stuff,
Uh-huh.
instead of writing out all the true and falses, like once there's a false in one of the premises, can you just stop writing the rest of the table out because you know it's not going to be valid?
Stop writing what out?
Like your first row where the opposite of P is false. Like, can you just stop there because you know if one of your premises is false, so it's not going to.
So you mean you'd have gotten here true, false, and you just wouldn't have done this?
Yeah, and then on the next one you have false right away, so I wouldn't even have done the other two.
I probably would be okay with that, yeah. But I still would like to see a circle, the one, just to be sure, the one that remains. Yeah, that makes sense. Okay, let's move on. Let's do number 5. Now, this one may seem strange because it's only got one premise. Sometimes that'll happen. So the 15, the premise is, if spouse is also filing, then give spouse's social security number. Wait a minute. I'm on 15. Sorry. The Good Taste restaurant has good food. That's just G, according to the book. Okay, there's your premise. Hence, look at, we're at the conclusion already. Hence, the Good Taste restaurant has good food, and I will recommend it to everyone. So, this is weird. The premise is just G, and the conclusion is G and R. R for recommend. Okay, this is a little different. So one premise, one conclusion. So I'm just going to copy the G. And now let's do G and R. G and R. Only true and both are true. Circle all the rows where all the premises are true. Well, there is only one premise. So, do you see how both these rows should get circled? And, of course, look, there's a bad boy there. One of the conclusions is false, therefore. So, please note, there's a varying number of premises. Could be 1, usually there's 2, sometimes there's more than that. Whatever number there are, they all have to be true for you to circle the rows. How about 7? Again, out of your book. If I work, then I have money. If I don't work, I have a good time. Therefore, I have good money. I have money or a good time. There's the argument. So, if I work, then I have money. There's premise 1. If I don't work, then I have a good time. That's premise 2. And the conclusion is, I have money or I have a good time. Let's check it out. Now, we have a problem already. We have 3 letters. Uh-oh. Well, it's not terrible. It just means that what? We have to have 2 to the 3rd power rows. We got to go from 4 to 8 on this one. So keep your eyes peeled for those too, okay? So here we go. I've already set it all up for you. Let's start doing the, I already did the not W up there on the left. So let's do if W then M. Rule, only false when the first one's true and the second one's false. So TT, TT, TF, TF, FT, FT, FF, FF. Okay, now, if not W, then G. So you got to go backwards here. You got to go from this column if this, and we got to go back to here. Okay, can you work backwards? Here we go. If false, then true. If false, then false. If false, then true. If false, then false. If true, then true. Oh, here's a bad boy. If true, then false. If true, then true. If true, then false. Another bad boy there. Let you catch up. You let me know if I goof, of course, please. We got one more column. Let's do M or G. And this is the inclusive OR. The rule is what? Only false when both are false. MG. True, true. True, false. False, true. False, false. True, true. True, false. False, true. False, false. Okay. Now, find all the premise rows. Excuse me. Find all the rows where both the premises are true. So, that's the first row, second row, this row, this row. Did I miss any? I don't believe so. Are any of the conclusions in the circled rows false? No. Aha! So this must be a valid argument. Make sense? Let's work on number 12. Maybe one more example, and then I'll let you have a little time off here. Okay, number 12. It says in the book, if you're enrolled or you have been accepted half-time at a college, you can apply for a loan. So that's that's a fairly complicated one. So if E or H, then A. There's our premise one. If E or H, then A. And the second premise is you have not been accepted half-time at a college. So not H. Conclusion, according to the book, is hence you cannot apply for a loan, so that would be not A. So is this a valid argument? Well, we got to do 8 rows again because we have 3 letters. So move this so we can see the 8 rows. And of course the 3 letters are E, H, and A. Remember the scheme for setting up a 3? You want to, in the first column, you want to do half and half. So if it's 8 rows, you want to do 4 T's and 4 F's. Now go half of that. Instead of going 4, go by 2's. 2 T's, 2 F's, 2 T's, 2 F's. And then go by half of that. Go by 1's. TF, 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 TF. So, you know, this one's complicated. We got to do all kinds of things here. Don't we have to do E or H before we can do anything here? So let's do that first. The OR rule, only false when both are false. TT, TT, TF, TF, FT, FT, FF, FF. Okay, now let's just copy A. I'm just not doing anything. I'm just copying column A so that I can... so what I'm going to do is I'm going to put my answer right in between them. Now let's if the left side, then the right side. Now we apply the rule, this guy, only false when the first is true and the second is false. TT, TF, TT, TF, TT, TF, FT, FT. So I'm going to just put an asterisk down here. That's kind of our, what? Results so far. Okay, now let's put the premise 2, not H. Yeah, maybe the only bad thing about the way I did is it's not going to be real easy visually, but that's okay. False, true, true, false, false, true, true, and not A, false, true, false, true, false, true, false, true. Okay, now, maybe to make it a little easier, should I cover these two up? You see, the problem is I don't want you to look at these two outside ones, so I'll be a little bit corny here. We'll put a rectangle in here, and I'll make them solid in a minute. Because I really don't want to look at those right now. Now tell me, which rows should I circle? Namely, which rows have all the premises true? Well, there's two P columns here. Well, this one. By the way, Josh, you probably in your efficiency ideas, you're probably thinking, do I need to go any further? Because I just saw it. Probably not, but I'm just going to keep going. Efficiency is good, by the way. Okay, do we have any false conclusions? Yeah, we even have a couple of them, don't we? So, does everybody see? This one's got to be invalid. Do you see why I covered those other ones up? Otherwise, it's going to look like we got non-F's in there, non-T's in there, and I don't know. That's the only disadvantage to doing a problem where you put the answer between. Okay, now, the other thing I need to talk, well, yeah, first of all, there is an error in the book. This doesn't happen real often, but I got to point it out. I don't know where that is. Example 2. Yeah, very top, page 156. Okay? Well, for one thing, do you see that word in the top premise? A whole number is even or odd. What kind of an OR is that? Well, the key question is, can a number be even and odd at the same time? No way. So that can't be this guy, because this guy allows both. So do you see why I can't use this guy, and I really should have used this guy? Well, they didn't. And look at the symbolism below. It's awfully dim, I know, but if you look in your book, you see how it says E, this O, that, what can I tell you? That's wrong. This symbol in the book should be. Now, I'll admit that they never taught this symbol, but still, it's not true to put that in there. So, I mean, the authors do a good job. I'm not trying to be critical, but I don't want you to take in that false stuff, okay? Does that affect the problem? Yeah. Remember, there's a different rule for this than there is for this. Right? This one is only false when both are false. This one is true only when they're different. And so, obviously, you have a different outcome. Okay? So we got that taken care of. And, yeah, there's the whole truth table. You don't have to look at it right now. But, I mean, they spent the whole page on this problem. Well, maybe not. Where did I get this from? Where is that? Oh, it's on the next page. Oh, it's on the bottom of the next page. Example 3. And again, they have it wrong. That E or O should be E, this guy, O. And, okay. So enough of that. Now, I got to show you this, I don't know what else to call it, but it's kind of like a domino effect. By domino effect, I mean, I'm sure you've all played dominoes in this way, where you stood them up and then you had the joy of pushing the end one and watching the chain reaction, that stuff. Have you ever seen some of those incredibly grand ones they occasionally will do? They go down the block and, yeah. Well, anyway, but this idea of tipping one, which causes the next one to fall, which causes the next one to fall, which causes this whole chain reaction, okay? That's the best way I can show you to show you this. We're gonna give you a problem like this, okay? And holy cow, look at, we have 4 premises. Anita told you we were gonna get the premises we're gonna multiply. But do you notice how they chain? It's like this. We say, hey, if you've got the letter P, then I'm gonna give you a Q. Oh, and by the way, if you have a Q, then I'm going to give you an R. And if you have an R, then I'm going to give you an S. And if you've got an S, then you get a T. So do you see how having a P causes this like chain reaction to occur? And if you get a P, you're actually going to wind up with a T? Can't you summarize that this way? If you start with a P, you're going to end with a T? So that's your first, like, chain reaction. I don't know what, honestly, I think that's a good title for this, even though the book doesn't use it. Okay. Now, they're not all that long. Like, look at number 23. I've got it at the bottom there. First premise is if P, then Q. Second premise is if Q, then R. Can you find the valid conclusion? Can you see how it chains? If P, then Q, and if Q, then R. Doesn't that tell you that if you start with a P, you're going to end with an R? Okay. Good. You see that? That's great. Now we're going to show you we're going to take one more step of complexity here. Okay. 22. That one's not very hard either. Here we go. Okay, now, here are 1, 2, 3, 4, 5 premises. Can you put them together to make a valid conclusion? Well, there's bad news. They don't all chain. You see that? Look, if P then Q, well, it does chain with this one, doesn't it? If P then Q, and if you have Q, then you have U, that's supposed to be, by the way. But then do you notice that there's nothing that begins with U? So we're kind of left hanging out to dry. Do you follow? So there's something wrong with this one. But there's a way out of it. You know, I don't like this not guy. And wouldn't it be nice if we could undo that not guy too? Actually, you've already learned, well, this one we've kind of learned. How many of you remember what's a way to take a statement like this and rewrite it so that it's valid? It comes from lesson 2 of this chapter. Yeah, when you say flip it, be more specific. You can't just turn them around. That's a converse. That doesn't work. But there is a kind of flip that will work. A contrapositive. Yeah, you remember what that is? That's where you do this, and you put knots on both of them. So, if we do that in that second statement, what would we get? Turn them around and negate them both. I lost my pen. If R, then not S? That's legit. Now at least, now does that do us any good? Well, I'll tell you what. What I'm going to do is redo the list over here. That one's good. I'm just copying if P then Q. I'm going to put this one next. Why? Because the Q's chain, right? Okay. Now we're kind of stuck. Now for this one, I got to have you look in a hint, which I believe they gave to you. I know they did someplace. I gotta find it. Give me a sec, please. I think it was in an assignment. From oh, you're looking ahead. Well, oh yeah, you're right. It's right in the hint. Thank you. I knew it was in a hint, but I thought it was back. It's in the hint. Take a look at the hint in the book, on number 23 of your assignment. It says, not Q or R is exactly equivalent to if Q then R. Oh, so what's that equivalent to? If U then T. Cool. I can put that right after this one. Look it. Now the U's change. All right, I can put the if T then R after it. Now that chains. And now can't I put this one at the end? Cool, they all chain now. And what's the result of the chain reaction? So if P then Q, and if Q then U, and if U then T, and if T then R, and if R then not S. So if you start with a T, therefore, if you start with a P, you're going to end up with a... Cool. So, you got these little puzzles, if you will. Chain reactions are cool. Sometimes, if it looks like one of the links is broken, guess what? There's always going to be a way that you can make the link work. And one of them is in that hint. Please note the hint in number 23 on this assignment. And don't forget your good old friend, Mr. Contrapositive, who allowed us to do the one toward the top. Okay. Well, guess what? If you look in your book, the numbers 22 through 27, those are the chain reaction guys. And so when you get into that section of the assignment, that's where you're going to want to pull those skills out. I believe it's 1 to 31 odds, but I want to double check. Yeah, there it is. 1 to 31 the odds. Thanks a lot.